We are going to continue on our journey in chapter 7. So we're continuing those roots and radicals. We're going to work on solving radical equations using the power rule. We're going to work with indexes greater than 2, so meaning that number, square root, a cube root, a fourth root. And then we're going to use the power formula to solve for a specified variable. If both sides of an equation are raised to a power, and that's the same power on both sides, it keeps the equation balanced. So it's just like when you multiply both sides by 2. If I raise both sides to the same power, I'm keeping things in balance. The power rule, however, sometimes will give you extra solutions. So there is an extra step in the solving process where you're going to have to figure out if all the solutions that you get satisfy the original equation. So think about this. If I have the square root of 4, that always has to be 2. But if I have a cube root of 8, that could be 2 or negative 2. So there's a chance that you could have something like that happen in the power rule where you have an extra solution and you've got to check it out. So when I have the square root of 5x plus 1 equals 4, the key here to help you know when to apply the power rule is when you have just a radical on one side of the equal sign, just a radical. Once you have that, you can raise the radical to the power and the other side to the power. Since it's a square root, the power of 2 will cancel it out. 4 squared is 16, and then you just solve it like a normal equation, and I get 3. I'm going to check it. 5 times 3, 15 plus 1 is 16, which is 4. So I don't have an extra solution. That is the solution. So if I was going to put this in steps, it's always isolate the radical. Get it by itself, then apply the power rule. So if I had a cube root, I would use the index 3 and raise it to the third power. If I had a fourth root, I would use the index of 4 and raise both sides to the fourth power. Then you solve the equation with the radical canceled. If it still, by some odd chance, has a radical, you repeat step 1 and 2, and then you check all solutions. If one of your solutions in the lab is wrong, the entire part is wrong. So it's really, really important for you to check those solutions, and that's where the most common mistakes are made in the lab, is you don't check a solution and you enter a solution that doesn't work. So here I have to isolate the radical. The radical is not by itself. I need to subtract 2 from both sides to get the radical by itself. Now it's just a radical, so I can apply the power rule and I can square both sides. But when I start to look at this, I have a negative 2. If you kept solving, like I said, if we square both sides and solve for x, when you go to check it, you're going to get an error. It's not going to work. Or at this step, you could recognize there's no way to get a negative answer out of a square root. So either place in the problem, you would recognize it because when you plug back in, it would not work. Here, the radical is isolated, but we do have to square both sides. And when we do that, we have to FOIL. So on the left, the root will cancel out, but on the right, we have to do the FOIL process of x plus 1 times x plus 1. Notice that's not x squared plus 1. There is a middle term because I had to FOIL. Then I'm going to combine my like terms. I'm going to move the x and the 5 over to the other side so that I can solve the quadratic. Now I have x squared plus 3x minus 4. And I'm going to need to factor that or use the quadratic formula to solve. So this is pulling back from the elementary algebra. If you need to, in the YouTube channel where I post these lecture videos, I have videos on factoring and the quadratic formula. If you just type in the search bar, you'll be able to find those. This does factor to 4 and 1. I'm going to set each one equals a 0. I'm going to solve for x. Now I have to check my answers. So I'm going to plug in And I look right off the bat, and -4 is not going to work, so you mark it off. It's not a solution. I plug in 1, and 1 is a solution. So this is where I talked about the whole we have to check our answers because there is a chance it may not work. And it's not a hard and fast rule that when there's 2 solutions, 1 doesn't work. That's not a rule you can apply. You just have to check all your answers. So here, the root is isolated, but I am going to have to FOIL the other side. Remember, that's not x squared, 1 squared. That is x plus 1 times x plus 1, which we FOIL out. Now we're going to combine our like terms and get everything on one side. Here, we don't have to factor a trinomial. I can just factor 2x out. Again, if you need to review solving quadratics, go back through that YouTube channel or go to Khan Academy and look at factoring. I set each thing equal to 0. I get 0, -2. I'm not done. I still have to check the solution. So I'm going to plug in for x in each one. And I'm going to see if it works. -2 does not work. If I plug in a -2, I do not get equal statements. And when I say plug in, you're plugging here at the top. So when I plug in -2, it is extraneous. So that means my only answer is 0. And again, is it a rule that 1 always cancels? No, that is not the rule. But you have to check. All right. This one's a little tricky. I have 2 radicals here. I'm going to get 1 on either side. Then I'm going to square it. I know that's kind of different, but you don't want to have 2 radicals and 1 FOIL because they won't cancel. So on the left-hand side, it's going to cancel out. On the right-hand side, I'm going to have to FOIL that. And this is where that extra step says that you repeat it again if there's still a radical. So I'm going to combine my like terms here and get all my like terms combined. The good thing is things are going to cancel and simplify. So I have x plus 1 on the left, and then I have my radical still on the right. Now that the radical is isolated, I don't want to divide by -2. You can square it with that -2 in there. I'm going to FOIL the left. -2 squared is 4. Square root squared is x plus 1. So it's a 2-step power rule process that has to happen because you still have that root. Then you're going to distribute to 4, and you're going to combine your like terms, and you're going to factor it. I'm going to check my solutions once I get them, and I find out -1 is extraneous. Is 1 always going to be extraneous? No. It might be. Now, there's nothing really different when I'm working with a cube root other than I'm cubing both sides. And then once I get rid of that cube root, I just solve it like normal. I would subtract 2x from both sides, and then I would add 2 to both sides, and that's how I get x equals 9. I'm going to check it. And guys, if you're not very good with cube roots, you can always use your Web 2.0 to check it. And you can type in the statement on the left and see if you get the same answer as the statement on the right. Now, there are formulas like pi r squared where we want to solve for a variable and then plug in. If I want to solve this for r, the first thing I need to do is get rid of that radical that's over a fraction. So I can get them individually over. Or, so if I do them individually over, I just need to get rid of the radical eventually. Or you could square both sides. Some people want to make it square root of r divided by square root of t. Then they want to bring the t over, and that's fine. You can definitely do it that way. Or you can square both sides to get rid of the radical right out the gate. Either way is fine. Then I would just multiply both sides by t, and I get it solved for r. So when I'm solving a formula, sometimes I'll get rid of the radical first. Most of the time, that's kind of my goal. But if you are someone who just out of habit does square root of r divided by square root of t, and you multiply both sides by square root of t, when you square it, you're going to get to the same place.